continuity and common functions. So what we're going to do is we're going to look at these functions and determine if they're continuous for all real numbers. What do you mean by all real numbers? That's really every number you can think of except for I, the imaginary number, which is square root of -1. So basically, if you were to graph it, does it work for every single number? Is there going to be some sort of discontinuity along the way? And we want to know for every single number. So log of x. If you think of log of x, and my recommendation for pre-calc, I'm just going to have you graph it. For calculus, though, you know what log of x means. So if you have y equals log of x, then this is a base 10. So 10 to the y equals x. You're trying to think 10 to what power is x. So what if x is usually the input, so we could pick a number. Can I use a negative number, though? Like 10 to what power is -100? What exponent is going to all of a sudden make your number negative? And you might think, oh, well, what about -2? No, because 10 to the -2 would be 1 over 10 squared, which is 1 over 100. It's a positive number. So what you'll notice is there's going to be no values for x that will work if they're negative. And check it out. If I graph it, see if I can find it. Look for log. Should be on here. There we go. Log x. And if I graph it, you'll see there's no negative numbers. So this is not going to work for all real numbers. All positive real numbers, but not any of the negative. Let's go ahead and think of cotangent. And you could probably already realize this one's going to fail as well. So you have g of x equals cotangent of x, and cotangent's cosine over sine. So can we divide by 0? No. So when does sine equal 0? Well, sine on the unit circle, right? Sine equals 0 here, and it just keeps going around and around and around. So there's going to be a bunch of discontinuities. And so that is not going to work as well. So we're going to go with neither h nor g is going to work. What about here? You're trying to think of values of x that wouldn't work. Well, technically, negative numbers are fine for exponentials, not for logarithms, because if you have e to like -2, that's just 1 over e squared. That's okay. But what about square root of a negative number? We can't square root negative numbers, so that's not going to work. So g is out. So it's going to be f only. What about cube root? Can we cube root negative numbers? And this one's not talking about all real numbers. This one's now talking about -2. Which of the following are continuous to -2? This is a little bit easier. We can plug a -2 in and see if it works. So h of -2. And of course, we should check the limit from the left and the right. But if you plug it in and it doesn't work, then automatically you know it's out. Cube root of -1. What times itself 3 times is -1? Well, -1 times -1 times -1, right? We'll give you that -1. Let's try this one, f of -2. Now, fourth root works a lot like a square root. We're going to have fourth root of -1. What times itself 4 times -1? Nothing's going to work. Just like the square root, you can't square root a negative, you can't fourth root a negative either, or sixth root a negative. You can't even root a negative. So h is going to work here, but not f. Then last, this one, we can see there's a discontinuity when x is 1, but this question is asking about -1. So if I try to find sine of -1 plus 1, that's sine of 0. And sine of 0 is 0. That's not undefined, that's fine. Just because 0 doesn't mean it's undefined. A lot of people get that a little bit mixed up. What about -1 minus 1? Well, that's going to be 1 over -2. That's fine, that'll work. So both of these will work. So that's the idea there. When they're asking about the real numbers, what values of x wouldn't work? If there's a value of x that won't work, then it's out. And then for when they give us a particular number, just try them out and see if they work.